Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at mitigating DHCP attacks. We'll be discussing a DHCP attack overview, DHCP snooping, steps to implement DHCP snooping, and then finally, we'll go through a DHCP snooping configuration example. This episode is part of my series on switching, routing, and wireless essentials for the Cisco Certified Networking Associate, also known as the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. One of the most common DHCP attacks we see is a DHCP starvation attack. What it does is it creates a denial of service. It uses up all available IP addresses in that DHCP pool, and then a legitimate client can't get an IP address to get onto the network to do what it needs to do. Mitigating DHCP spoofing attacks requires a little bit more setup and configuration to stop that from happening. There's software out there that will go and make a request on a MAC address, get an IP address, change its MAC address, and make another request and use up all those IP addresses. What happens is that software can be configured to use the actual internal MAC address, so it looks legitimate, like the source Ethernet MAC address, and so it does look legitimate. And then what it can do is it can specify a different MAC address in the DHCP payload, and that would cause the DHCP server to see it as a different MAC address and hand out an IP address to that. This renders port security ineffective. Once again, how this works is that software, when it plugs in, it uses the actual MAC address of the actual device. And so it gets the connection into the switch. Once it gets that, when it goes and it makes the DHCP discover request, the DHCP payload, it puts in a different MAC address. Because we already have that connection using a legitimate MAC address, we can get onto the network. And then when we make that DHCP discover, because we have the DORA process again, we make that discover, we use a different MAC address at that point in time. Or we could do the discover with our correct MAC address. We get the offer, and then we send back the response with a different MAC address. There's a couple different ways of doing it in there, but basically it gets by port security. Yes, you can mitigate it with port security, but then you can also get around it also. And in order to mitigate this whole thing, what we do is we use DHCP snooping. DHCP snooping filters DHCP messages that DORA process and also rate limits DHCP traffic, those requests on untrusted ports. And so what we have to do is we have to go in and set up trusted ports. Device under administrative control are trusted. And what that means here is administrative control is the devices we set up, the devices we went in and we configured, we know aren't compromised, they are set as trusted sources. We also go in and trust interfaces. Now, you can go in and trust this interface, but you have to go into the actual interface itself and say, you are a trusted port. Now, this would maybe be a port to a trunk to another switch. That would be a trusted port. Now, devices outside of the network and all access ports, anywhere an end user plugs in, those are untrusted. And those will have their DHCP messages filtered, and they'll also have them limited. Your DHCP table is built on that DHCP server. It includes the MAC address that did the requesting of that untrusted port, and then it's the IP address that's assigned to it. Those two are bound together. And what we do is we call this a DHCP snooping binding table, and it binds those together. And so we can keep track of the information of the MAC address and the IP address and what ports they're on. Here's an example configuration of DHCP snooping. First, let's look at our switch in the center. And we have two ports connected in. We have Fast Ethernet 5 connected to an end user device, an access port, PC, and then we have Fast Ethernet 01 that's connected into a DHCP server. What we're going to do is we're going to trust the Fast Ethernet 01 because it's connected to our DHCP server. Now, if we would limit the number of DHCP traffics and filter that out on the switch, our DHCP server would probably get limited, and you don't want that to happen, because like at 8 o'clock when everybody starts in the office, they turn their computer on and they have DHCP traffic coming in. Well, from one computer it's okay, but then you've got 40, 50, 200 people all trying to get IP addresses where they're on their individual ports, probably not getting rate limited, but that DHCP server is going to get limited. So we want this to be a trusted port where we're not going to have any limiting or filtering happening. Configuration here is IP DHCP snooping. We have to turn it on first. IP DHCP snooping turns it on. Then what we can do is we go into the interface. Interface to Fast Ethernet 0, that's the one connected to our DHCP server. We're going to say IP DHCP, and then we're looking at the snooping settings, and we're going to say you are a trusted port. We are trusting this port we went into, this Fast Ethernet 01. Now we can exit out, we can go in and do a range of ports. Now we're going to say that the ports 20 or ports 5 to 24, and we're going to use our range command. What we're going to do is we're going to set the snooping limit of 6, and that sets our limit at 6. Exit out, and then we're also going to turn snooping on these VLANs 5, 10, and 50 to 52. So 51, 50, 51, and 52, those 3 VLANs. To verify our DHCP snooping, there's 2 commands we can use. First one is show IP DHCP snooping. That is in privileged exec mode. First line here is DHCP snooping is enabled. It's configured on these following VLANs 5, 10, and 50 to 52. That's what we just specified when we set it up on the previous screen. Coming down through here, we're looking here. We're saying, getting into our interfaces, Fast Ethernet 01. It's a trusted interface. Remember, Fast Ethernet 01 was connected to the DHCP server, so we don't want to limit this traffic. Plus, it's under administrative control. We trust it. We assume it hasn't been compromised. And notice the rate limit. Rate limit is unlimited. Then we can look at the other ports, and that's where we did the range of 5 to 24. So here's Fast Ethernet 05. It's not a trusted port. It's an access port where end users can connect in. What we're doing is we're stopping threat actor from unplugging that desktop PC and then plugging in his own device to compromise our network. And we have a rate limit here of 6 per second. Fast Ethernet 6, and it'll list out all of those ports there. Other command we can use here is show IP DHCP snooping binding, and that builds that table here. This is the MAC address. This is the IP address that's associated with it. How much is the lease time in seconds? We are doing DHCP snooping on it, what VLAN and what interface. That's all the information there in our DHCP snooping binding table. It was my pleasure to provide you with this wonderful episode on mitigating DHCP attacks. If you like this episode and you got value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on switching, routing, and wireless essentials for the CCNA. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on switching, routing, and wireless essentials for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.